physics. We covered something called the geosphere, the solid earth, tectonics, soil. Yesterday, I introduced the hydrosphere, watersheds. Today, we look at the atmosphere. It's also a fluid. In physics, we think of air as a fluid because it moves in the same ways. We've got our lithosphere and our mantle and our core. The atmosphere is a layer too, a layer of gases. And it is thin. And it's amazing how important that tiny little band of pretty blue is to our survival. We have to have it. And it's also one of the easiest things for us humans to mess up in terms of climate. Do we know the answer? It's not helium. Is it A, B, or D? It's B. Argon is third. Now, they're all very small once you get past nitrogen and oxygen. Nitrogen is 78%, and so that only leaves a small percentage left for the rest. You can see carbon dioxide is one that we care a lot about. It's a very tiny sliver of our air, but it's what we call a greenhouse gas. And so it can have very powerful effects if it goes up like it has been for the last 200 years. Water is an interesting one. There is water in our air, right? When water evaporates, water vapor. The water vapor is a strange one because it's not constant. The others are all kind of constant, but water vapor can be anywhere from 0%. Think of the coldest days in the middle of the winter. And that's when we all need chapstick, right? Because there's no moisture in the air, no clouds, perfect blue sky. It's -3 outside. That means 0 moisture in the air. And then think of the hottest, sweatiest, grossest day in the middle of August, high humidity. We can have up to 4% of our air be water. And those are the days where you really, really hope you have air conditioning. All right, so water vapor is a weird one, can be between 0 and 4%. And there's all kinds of other stuff. But do you realize that when you take a breath, when you breathe in, you're breathing in a mixture of gases. You are breathing in mostly nitrogen, and your body doesn't need the nitrogen, at least not in that form. And so the nitrogen basically goes in and comes back out. It's one of the things you exhale. You know, as I mentioned earlier, the atmosphere is just another layer, but it's a little more complicated than that. It's actually layers, plural. So if you were to go higher up in the atmosphere near space, the concentration of gases would change. There actually would be a lot less gases. And up near the top, you're mostly breathing hydrogen and helium, the two simplest elements, the two lightest elements, and that's why they're on the top. It's density, right? The light stuff floats to the top. And so hydrogen and helium are the most common substances in the universe. But for us, they're mostly just tiny little atoms up at the top of our atmosphere. You can see in the clouds sometimes that our atmosphere has layers. That's a tropical storm, and you can see that the top of it is flattened out, like there's an invisible lid sitting on top. The bottom layer, where those clouds are at, where we live, anything from the ground to the top of those clouds is called the troposphere. And I'll spell that for you in just a minute. I've got a picture with all the layers on it. So it's called the troposphere, and it's obviously to us the most important layer, right? Because it's where we live and where the gases are that we need, and it's where weather happens. We wouldn't have weather if the troposphere didn't work the way that it does. But then there's that invisible lid that we can't see. Layer 2 starts, and the clouds stop, and the next layer is called the stratosphere. You've probably heard of that. Jets like to fly in the stratosphere. They get up above the clouds and they cruise. They can go much faster. There's obviously no storms, and there's a lot less matter. Now, they need enough matter to hold their wings up, but they can fly through the air easier because it's not as dense. So they fly in the stratosphere. The top of the troposphere is the tropopause because it's switching. And then we hit stratosphere and then stratopause. Mesosphere, mesopause. Weather happens in the lowest layer and only the lowest layer. There is more air pressure in the troposphere than in the other layers, and that's just density. We've got the weight of all the air pushing down on that bottom layer. It's like, remember I said that air is like a fluid? It's like being in the deep end of a swimming pool. If you dive down to the bottom of the pool, your ears feel that pressure. Well, the atmosphere is just an ocean of air. The red line is simply showing you how temperature changes with altitude. Now, we kind of know this. If you climb up a mountain, it gets colder. And there's snow on top. We expect that. Okay, so that bottom line makes sense. It's a very linear equation. Every 100 meters that you go up, you lose about 1 degree Celsius. It's called the normal lapse rate. As the air spreads out, there's less friction, less collision of the molecules. And so thinner air is cooler. And it's quite a bit cooler. You go to the top of Mount Everest and you can freeze to death. There are glaciers that are permanent ice caps on the top of many of our mountains. All right, so nice, easy cooling off as we get up to the top of the troposphere. And then we have the change. Okay, so here's a major important question and answer for you. Why does the atmosphere have 4 layers? The answer is because of temperature. It is where we mark the change of each layer, where the temperature changes. We're going to go from decreasing temperature in the troposphere to increasing temperature in the stratosphere. So it starts to get hotter again. Now, it's still getting less dense. So why does it get hotter? The answer is what you see off to the left. We have a very special collection of gas. It's a gas called ozone. And we'll come back to ozone too, a very important climate topic. Ozone is O3, right? Oxygen that we need to breathe is O2. You add 1 extra oxygen atom and you get this crazy thing called ozone. Ozone down here in the troposphere is poisonous. If we breathe it, it would make us sick and it could kill us. It's actually one of the ingredients of smog. But ozone in the stratosphere is life-supporting because it blocks ultraviolet radiation, the stuff that we wear sunscreen for. It blocks a lot of it, not all of it. It doesn't just block it, it absorbs it. It absorbs the energy. And so when you take in energy, you heat up. And that's why the stratosphere gets warmer. We run out of ozone up there at the stratopause, and things go back to normal. In the mesosphere, there's really nothing special about it, except that it gets colder again. The line switches back, and that means we have a new layer. And then we get up to the mesopause, and there's very little atmosphere left, less than 1% above the mesopause. And really, that last layer is barely a layer. It's just the blurry boundary between Earth and space. Earth does not have a solid edge. We always see it in a picture. It looks nice and round and perfect. But that last layer is a blurry mix, just like at the ocean where saltwater and freshwater mix. We have space, which has no atoms, mixing with the Earth, which has just the very first few light atoms, hydrogen and helium, up at the top. Now, something awesome happens there, and it's going to be tied to tomorrow's story time. In the thermosphere, and therm means heat, right? You see it gets much hotter in that top layer. It is our first line of defense. If something is flying through space, a little piece of rock, and there's nothing in space to slow it down or to hit it, no air resistance, no friction, and all of a sudden it's cruising along at thousands of miles an hour, and it slams into a hydrogen atom. Teeny tiny little hydrogen atom. Who cares, right? Well, the hydrogen atom cares, and basically it explodes, and that gives off heat. Okay, so it's the very first thing it hits when it gets to our planet. It smashes into a few atoms here and there, and That's why meteors burn up. All right, so the thermosphere is hot, and it's our first line of defense, and it's just where ions and little pieces are crashing into atoms. So it's a zigzag pattern. Cold, troposphere, warm, stratosphere. Cold, mesosphere, warm, thermosphere. If you understand that and some of the basic reasons why, you should be in good shape. Here's just an image showing you of how the ozone works in the stratosphere. And there's 3 different kinds of ultraviolet light that come from the sun. And it blocks out all of ultraviolet C, the highest frequency. It blocks out most of ultraviolet B, and it blocks out only a little bit of ultraviolet A. So that's why we wear sunscreens. This is proof of what's happening in the thermosphere. When auroras hit the atmosphere, they're not flat. They streak as they come in. That's the tail of the space shuttle. And the astronauts were looking out the back, and they could see the auroras streaking into the planet. And I just can't imagine, not only is it beautiful, but to think of the engineering that humans figured out a way to get there and take that picture is mind-boggling to me. And I'm jealous. I would love to do that. These are right off of an old AP exam, and so I thought it would be very good practice today to kind of quiz yourself. Letter A, which is the warmest layer of the atmosphere? Thermosphere. Therm means heat, temperature, right? So warmest is therm, the top one. Letter B, most of the water vapor is found in this layer. Where would we get water vapor? Well, that sounds like rain. That sounds like weather. And so that's got to be the bottom layer, the troposphere, for letter B. Letter C, the layer where nearly all weather takes place. We just answered that. It's troposphere as well. Letter D, the highest concentration of naturally occurring ozone. Well, that should be pretty easy. That's the stratosphere. And that's why the stratosphere gets warmer. And finally, characterized by decreasing temperature with altitude. Uh-oh. Decreasing temperature. Well, that's got 2 answers, right? There's 2 of them that decrease. Troposphere on the bottom and mesosphere in the middle.